Hello everyone, this problem has been asked in GATE 2018 and this problem is from Electromagnetics part and it is of 1 mark. GATE 2018 EMFT part and it is of 1 mark. The problem says that a positive charge of 1 nanocoulomb is placed at 0.2 where all dimensions are in meters. Consider the xy plane to be a connecting ground plane. Take epsilon naught is equal to 8.854 into 10 to the power minus 12 farad per meter. The z component of the electric field at 0.1 is, and the options are shown here. So for the detailed concept behind solving this problem, you can kindly refer this NPTEL lecture Electric Potential 1 and the course name is Electromagnetic Theory by Professor Pardeep Kumar, Department of Electrical Engineering, IIT Kanpur, and the YouTube link is also given here. So before we begin to solve this problem, let us have a quick recap about the expression that we use for the electric field. So according to Coulomb's law, the force between the two charges Q and Q naught separated by distance r is given by this expression. So this is only magnitude. If you want to write the vector form, then you can write and you can represent 1 divided by over 4 pi epsilon naught by k into q naught, and here you can represent vector r, then downside will be r cap r vector to the whole q. Similar, so where epsilon naught is the absolute permittivity of free space, that is we know that 8.854 into 10 to the power minus 12 farad per meter. Therefore, we can also find the electric field intensity at that point at the distance r from the charge q, and this expression is is equal to F divided by Q naught. So it will come as 1 divided by 4 5 epsilon naught Q divided by R square. In the vector form, you can write it as K Q R vector, and downside will be denominator side will be RQ, magnitude of RQ. This above expression represents the electric field due to a point at distance r. Now let us solve this problem. So here what things are given? Given that a positive charge a positive charge of 1 nanocoulomb is placed at 0.2, and we know that according to sorry according to method image charge concept method image charge concept image charge concept, there will be an image charge below the conducting ground plane. So therefore we can make this figure like this. Suppose this is ground plane, then we can we are having this 1 nanocoulomb charge. 1 nanocoulomb charge is present as 0.2, and therefore according to image charge concept, this opposite charge will be presented 0 minus 0.2, and we have to find this electric field at 0.1. So we have already seen how to find the electric field. The expression is K into Q r cap r vector divided by r vector, magnitude of r vector to the q. So first we are going to find the electric field at point P due to point charge plus 1 nanocoulomb. So now this is the expression that we are going to use. So first we are going to find the electric field at point P due to point charge plus 1 nanocoulomb. So let us take it as E1. So E1 will be 1 divided by 4 pi epsilon naught, that is K value, and and this Q is 1 into 10 to the power 9. Now we have to write this R vector. So take the initial point and then the final point. Yes, where we have to find, take it to the initial point. So 0 minus 0 x cap plus 0 minus 0 y cap plus 0.1 minus 0.2 z cap divided by RQ. So if you see here, it will be magnitude will be 0.1. So you can rightly write 0.1 Q. So E1 vector will be 1 divided by 4 pi into 8.854. Sorry, it is given 8.85 only, into 10 to the power minus 12 into 1 into 10 to the power minus 9 minus 0.1 z cap divided by 0.1 q. So it will be, we can write E1 is minus 889.18 z cap volt per meter. Now we are going to find the electric field at point P due to point charge minus 1 nanocoulomb. So electric field at point P due to point charge minus 1 nanocoulomb. So let us assume it as E2. E2 is KQ R vector divided by magnitude of R vector, R, and that is cube of the magnitude of R vector. So substituting all this value, 1 divided by 4 pi epsilon naught into minus will become, so minus 1 into 10 to the power minus 9, and taking initial value at the point where we have to find the electric field, 0 minus 0 x cap plus 0 minus 0 y cap plus 0.1 plus 0.2 z cap divided by, so here we can see that magnitude of r vector is 0.3, 0.3 q. So write this r vector carefully. You have to take the point where you are going to find the final electric field, then you have to take it as here, and then, and with reference to with reference second point you have to take it second. So like in we have written here 0.1 minus 0.2, so this one is the point where we have to find, and this minus 0.1 is the point where this charge is present. So just take care this thing carefully so that you will not do mistake in exam. 1 divided by 4 pi into 8.85 into 10 to the power minus 12, it will be minus 1 into 10 to the power minus 9 into 0.3 z cap. Zero 0.3 z cap divided by 0.3 q. So if you do simplification, then E2 will come as minus 99.90 z cap volt per meter. Therefore, total electric field will be, electric field at point P will be E1 plus E2. So E1 we have found that is 889.18 volt per meter Z cap, and E2 is minus 99.90 Z cap volt per meter. So summation of this will give us 999.08 Z cap volt per meter. So this direction is in the downward direction. So that is Z component. In this problem, it is asked about the Z component of the electric field at the point 0.1. So correct answer will be D, minus 999.09 volt per meter. That's all. Thank you.